All right, hello. How are you guys doing today? So we're going to continue on. So last time we talked about this page here where we learned how to write an augmented matrix that looks like this, where this side is the coefficients and then this side is the constants. All right. And we also talked a little bit about doing row operations on a matrix. And row operations are just when we make a new row using the entries of the old rows, and we can multiply them and then add them to our original row. Okay. So we learned how to do that. Now today we are going to talk about why we learned to do that, because we're going to use those things to solve systems of equations. More solving equations. All right. So first, let's talk about a couple of new words. Um, here we are going to be talking about something, a way of writing our matrices. All right, we are going to use the row operations that we learned last week, and we're going to keep using those row operations to make our matrix look a certain way. We want our matrix to look like this. All right. Now, what is special about this? Well, you can see here that on the diagonal, there are ones. All right. So we want to make the diagonal of our matrix have only ones. 1, 1, 1. And then the other important thing is that underneath the diagonal has to all be zeros. All right. All right, 1, 1, 1, and then 0, 0, 0 underneath the ones. Now, on top here, these ones right here, they can be numbers. A, B, C. That just means any numbers. It could be 10, 15, 34, -6. It doesn't matter. And D, E, F are also going to be numbers. The numbers on the constant side of our augmented matrix, they can also just be numbers. All right. So the important thing that we need to get is just this 1, 1, 1 on the diagonal, and below the diagonal, we want it to be 0, 0, 0. Now, when we get our matrix looking like this, we have a special name for it. This is called row echelon form. All right, so when our matrix looks like this, 1, 1, 1 on the diagonal and zeros below, and then these ones can be any numbers. If it looks like this, then we say this is row echelon form. All right. Now, why do we want to get our matrices looking like this? The reason we want them to look like this is because, remember, if we write this as a system of equations, these are the coefficients. So we have x plus ay plus bz equals d. And then this one is, we don't have an x, we just have y plus cz equals e. And then the final one is just going to be z equals f. Oh, so the reason we like this is because when we have our matrix written like this, we know that the variable z is going to equal this number f. Now remember, f is just a number. It could be 6 or -3 or 45. It doesn't matter what number it is. All right. So if we get our matrix looking like this, we know z. And then we have an equation up here that just has y and z, but we already know z. So we just need to find y. We'll be able to do that very easily. And then we'll have an equation that has x, y, z in it, but we already know y and we already know z, so we'll be able to solve for x. So once we get our matrix looking like this, it will be easy for us to solve it for all of the variables. Now, I realize that as I say that, it might be difficult to understand what I mean, but let's practice a couple of problems and you'll start to understand. Now, another way, before we practice some problems, another way we can make our matrix look is something called reduced row echelon form. Now, reduced row echelon form is when our matrix looks like this. Now, what is this matrix? This is the identity matrix over here, 1, 1, 1, and then zeros everywhere else. And then on this side, we just have some constants. So what does this mean? This means x equals A, y equals B, and z equals C. All right, so that's what this means. Now, don't worry about this one for now. Right now, we're going to be trying to get our matrices to look like row echelon form. This one right here. Okay, so how do we do this? Now, we're going to do number 7 here, and you see there's a lot of space here to write because there's a lot to write. All right, so we're going to work on this together. I'll show you how to do it. Now, there are some steps that we're going to take. All right, so I'm going to write the steps down. All right, so right here I'm going to write step 1. All right, so what is step 1? We want to write the augmented matrix. All right. I forgot how long it takes me to write with my mouse. It takes too long. Augmented matrix. I need to get a pen so that I can write faster. Okay, so we have augmented matrix. That's the first part. We want to change this into an augmented matrix. Well, we learned how to do that yesterday. It's not very hard. All right, so we have the coefficient of x is 2, the coefficient of y is 2, and the coefficient of z for this one is 0. And then we draw a line, and then we write the constant 6. And then we have 1, 1, 1, 1. Oh, so this one's just going to be 1, 1, 1, 1. And then this one's 3, 4, negative 1, 13. 3, 4, negative 1, 13. Okay, good. So that is step 1. Pretty easy, right? No problems there. Let's go on now to step 2. All right, so we have step 2 now. What is step 2? Step 2 is that we want to make the first row, first column, so this one right here, we want to make that a 1, right? We want to make it a 1, all right? We want it to look like this. So we need to make this into a 1. So that's the next step. So I'm going to write put a 1 in position. It takes forever. Position. And I'm going to write position 1, 1. Now 1, 1, I'm just going to write as first row, first column. So 1, 1. This position right here, we want to make it a 1. Now how do we do that? We have to use the row operations that we learned yesterday. Not yesterday, on Friday. All right. So the row operations, remember what row operations can we use? We can interchange any rows. All right. So one way we could do this, and we could do it this way right here, is we could just switch these two rows. All right. If we move this row, row 2, into the row 1 position and put the row 2 into the row 1 into row 2 position, then we did step 1. Check, because we put a 1 in position 1, 1. That's one way we could do it. Now, I'm not going to use that way right now, but you could do that. That's fine. All right. The other thing we can do is we can replace a row by a non-zero constant multiple of the row. So that means we can just multiply the row by a number that is not 0. You can't use 0, but you could use any other number. Now, that's the row operation that I'm going to use right now, because what can I do? I can multiply everything in this row by 1/2. If I multiply everything in this row by 1/2, then I'm going to get a 1 here, right? That's what I want. All right, so I'm going to write down the row operation for that. What's the row operation going to be? It means our new row 1, which is big R1, is going to equal 1/2 of old row 1. All right? That's how we write this in row operation notation. All right, so the new row 1 is just going to be half of the old row 1. And so let's write that down now. Our new matrix then is going to look like this. We're going to multiply everything in row 1 by 1/2. So it's going to be 1, 1, 0, 3. Right? Isn't that right? We just multiplied everything by 1/2. That's okay. We can do that. And then everything else isn't going to change. 1, 1, 1, 1. And then we have 3, 4, -1, 13. Okay, good. So step 1 is finished. Step 2 is finished. This is step 2. All right, step 1 is finished, which was just to write the augmented matrix. Step 2, which is to put a 1 right here, is also finished. We did it. We put a 1 here. All right, next, we're going to move on to step 3. Now, step 3 is a little bit more challenging, but it's not too bad. All right. So what is step 3 going to be? All right, step 3 is that so remember, this is row echelon form, all right? We have a 1 here, but we need to have zeros below it. So our next step is going to be we want to put zeros below position 1, 1, all right? So we want to put zeros, I'm going to put like that, zeros below 1, 1. All right. So we want to put zeros here and here. And we have to use one of our row operations to do that. All right. So let's first look at row 2. How can we put 0 here? We want to put a 0 here. Now, we can't, the first row operation is to change the rows, right? We could just move the rows around. We could switch this row and this one. But there is no rows with a 0 in front here. So switching the rows is not going to help us. The other thing we could do is multiply. Remember, the second row operation is to multiply every number here, every number in the row by some other number. Now, remember, we can't use 0. Since we can't use 0, this isn't going to work. There is no number that we can multiply by 1 to make it equal 0. The only one that we can use is 0, but that's against the rules of row operations. We can't use 0. All right? So we can't do that one. So we have to use this third row operation. Now, remember, the third row operation is what we practiced on Friday. It's where we take a row, we multiply some other row by a number, and then add it to this row. All right? So that's what we're going to do here. And it's not too hard. All right? So look here. We have a 1 here, and we have a 1 here. Now, what if we just take this row, the first row, if we multiply it by -1 and then add it to this one, we're going to have -1 times plus 1, which will make a 0. That's what we're going to do. All right, so how do we write that row operation? Well, we're making a new row 2, so we're going to write big R2, all right? And how are we going to make our new row 2? We're going to multiply the old row number 1 by -1. So we're going to take negative of the old row 1, and we're going to add the old row 2 to it. All right. If we do that, we're going to be able to get rid of this 1 and make it into a 0. All right. We'll do that in just a moment. But we also want to get rid of this row 3. There's a 3 here. We want to make it equal 0 too. So we want to make a new row 3. Now, how can we get rid of this 3? Well, we could multiply row 1 by -3, right? If I multiply this by -3, we get -3, and then we can add it to old row 3, which is 3. -3 plus 3 will make a 0 there, and that's what we want. All right, so how do we write that? We're going to write -3 times old row 1 plus old row 3. All right. So this is just like what we were doing on Friday, where we have numbers here and we have row operations and we have to use those row operations. But we are now doing the row operations to try and meet our goal of putting zeros here. All right. So let's do this now. All right. How are we going to do this? Well, our top row, row 1, is not going to change. So let's write 1, and then I'm going to give some space here, and then 1, and then some space, and then we have a 0, and then we have a augmented matrix, and then we have a 3. All right, so that's first. All right. Now, let's look at row 2. Now, our new row 2 is going to be negative row 1. So for here, row 1 is 1. So -1 plus old row 2, which is this one, which is 1, plus 1. All right, good. And then let's go here. What do we have? Well, again, we have old row 1, and we're going to make it negative. So that's -1. And we're going to add old row 2, which is 1. Okay? And then right here, we're going to have old row 1, which is 0, make it negative, which is still 0, and we're going to add old row 2, which is 1. So that's just going to be 0 plus 1. I'll write it out. 0 plus 1. All right? And then, finally, over here, we're going to have old row 1, make it negative, so that's -3. And then we're going to add old row 2, which is plus 1. Right? Okay, good. So that's the second row. Now let's look at our third row. We're going to use this row operation. All right? So how do we do this? Well, we're going to -3 times old row 1. Well, old row 1 is 1 here. -3 times that is -3. And then we're going to add old row 3, which is this one, 3. Then here we're going to do -3 times old row 1, which is 1. So we have -3 plus, so we have -3, and then we have to add old row 3, which is this one, 4. All right, then right here, we're going to have -3 times old row 1, which is 0. So -3 times 0 is 0, plus old row 3, which is just -1. All right, and then finally, we're going over here, we're going to have -3 times old row 1, which is 3. So -3 times 3 is -9. And we're going to add old row 3, which is 13. All right. So now we just need to add we just need to calculate all these. We're going to have the first row is going to be 1, 1, 0, and then 3. And then we have -1 plus 1 is 0. -1 plus 1 is 0. And then 0 plus 1 is 1. And then we have -3 plus 1, which is -2. And then we have -3 plus 3, which is 0. negative 3 plus 4, which is 1, and negative 1 right here. And this is going to equal negative 9 plus 13, which is positive 4. Okay, so we've done this now. We have step 2 was to put 1 right here, and then step 3 was to put zeros below it. Well, we did that. So check, we're done. Next, let's go to step 4. All right, so step 4, what we're going to do is we want to put a 1 here, and we want to put zeros below it. So it's kind of a combination of step 2 and 3, but it's for the next column. So we want to put a 1 in position 2, 2, right? That's the second row, second column right here. We want a 1 right here, all right? And zeros below, all right? Now, this could take a couple of steps here to do step 4, because sometimes it will take a few different row operations to do this, all right? But in this example, it's actually very easy, because if we want to put a 1 here and a 0 below it, well, there's an easy way we can do that, because one of our row operations is to switch the rows, right? So what if right now we just switch row 2 and row 3? That'll put a 1 here, and it'll put a 0 below it, right? So let's do that, all right? And if we want to write that, we could write our new R2 is going to be old R3, and new R3 is going to be old R2, all right? So that's how we write this in the row operation notation. And we can go ahead and write our new matrix. The row 1 doesn't change, so it's going to be 1, 1, 0, and then 3. And then 0, and then now we want row 3 to move up here. So we're going to have 0, 1, negative 1, 4. And then below that, we're going to have the old row 2, which is 0, 0, 1, negative 2. All right, good. Now, step 5. All right, so this takes a long time. The next one will go faster because I won't explain each step, all right? But this lesson is going to be long. I'm sorry. Today's Monday. Yeah. All right. Sorry. It's going to take a little bit longer today. Step 5. We need to keep doing. Oh, what is that? Dang it. Oh, no. It takes me so long to write things. Okay. I'll get a pen next week. Keep doing step 4. For the rest of the columns. I'm not going to write this whole thing out because it's taking me forever. Keep doing step 4 for the rest of the columns. So we put a 1 in 2, 2. So now we're going to have to put a 1 in 3, 3. And also zeros below that. And a 1, if we have a bigger matrix, then we put a 1 in 4, 4, and 1 in 5, 5, and zeros below all of that. But we're just doing a 3 by 3 matrix, so the last step is just to put a 1 right here. But in this one, there already is a 1 there, so we're done. And notice, what form is this? We already have row echelon form. 1's down here, right? We have 1's like this, and we have zeros below the 1's. All right, so this is row echelon form. We already have row echelon form, and that's what we wanted. All right, so the last part, all right, step 6, this is the last part, is now that we have row echelon form, we can solve, all right, we can solve for each variable using the system of equations that this one represents. What does this represent? Well, this represents we have x plus y equals 3, right? X plus y equals 3. We also have y minus z equals 4. And we have this one, we have only z equals -2. Now remember, I told you when we have row echelon form, we're always going to have the last row is going to be z equals something. So we already can find our z. We know our z immediately, all right? All right, so now we can just solve for everything. Since z equals -2, that means we can put the z into here, and we're going to have y minus -2, which is y plus 2 equals 4, which means that y equals 2, all right? And then finally, because we know that y equals 2 and z equals -2, we can put that into here. So x plus y, and y y is 2. So x plus 2 equals 3, which means x equals 1. So we found that x equals 1, y equals 2, and z equals -2, and that's our final answer, okay? Takes a long time. I spent 20 minutes going through that problem. I'm sorry. All right. Now, but I have bad news for you because we're going to do another one now. All right. So we're going to go through this one. I'll go a little bit faster, all right? I will talk as I do it, and I will go as quickly as I can. Now, step 1, we need to write the augmented matrix. All right, so 1, -1, 1, 8. Then we have 2, 3, -1, -2. 3, -2, -9, 9. All right, so this is our augmented matrix. Good. Next, step 2. What's step 2? We want to make a 1 here. Oh, good. There is a 1 there. So we don't need to do step 2. We're done with step 2. So let's move to step 3. What is step 3? We need to put zeros below the 1, right? We want a 0 here and a 0 here. All right, in order to do that, we can use row operations. We're going to make a new row 2, and we're going to make a new row 3. All right, how are we going to make our new row 2? Well, what we're going to do, since we want this to be 0, we're going to multiply the top row by -2, and then we're going to add it to this one, because -2 times 1 is -2, plus 2 is going to give us 0. So we're going to do -2 times row 1 plus old row 2. All right? Got that? And then for row 3, we're going to do the same type of thing. We're going to multiply the first row by -3. All right? -3 times row 1, and we're going to add it to old row 3. So -3 times 1 plus 3 is going to give us a 0. All right? So now I'm going to go ahead and I'm going to do these as much as possible in my head so I don't have to write everything out. All right? Now you might want to write everything out. That's fine. All right, so row 1 is not going to change. We're going to have 1, -1, 1, and then we're going to have 8 here. Boom. All right, now row 2. How are we going to do row 2? We're going to negative 2 times this one plus this one. So negative 2 times 1 plus 2 gives us a 0. Negative 2 times negative 1 gives us 2 plus 3 gives us a 5. Negative 2 times 1 is negative 2 plus negative 1 is a negative 3. And then negative 2 times 8 is negative 16 plus negative 2. Negative 16 plus negative 2 is negative 18. All right, make sure that I'm going to make sure that I got that right. Yeah. Okay, good. All right. Next, let's look at the third row. All right. So we're going to do this. We're going to multiply by negative 3 and then add this. So negative 3 times 1 is negative 3 plus 3 is 0. Then negative 3 times negative 1 is positive 3 plus negative 2 is 1. Right? And then we're going to do that here. Negative 3 times 1 is negative 3 plus negative 9, and that's going to give us negative 12. And then finally, we're going to have negative 3 plus times 8, which is negative 24, plus 9. Negative 24 plus 9 is negative 15. All right, good. So that's the end of step 3, all right? Remember step 1, writing this. Step 2 was putting the 1 here, which we already did. And then step 3 is to put zeros underneath. We did it. Next, what are we on? Step 4. All right, step 4 is we want to put a 1 right here in the 2, 2 spot, and we want zeros below it. So our first step to do that is we're going to switch these 2 rows, because here's a 1. We can just put it up here, right? So let's do that. All right, so how do we do that? We're going to do R2 equals old R3, and new R3 is going to equal old R2. All right? All right, so let's write our matrix here. All right, and we're going to have 1, negative 1, 1, and then we're going to have 8. And then we're going to switch these rows. So this is going to be 0, 1, negative 12, negative 15. All right, and then we're going to have 0, 5, negative 3, and negative 18. Okay, good. All right, now let's look at this one. What do but the next part of step 4 is we need to get a 0 here. Now, just like what we did up here, the way we're going to do that is we're going to change row 3. So we're going to have a new row 3. And the way we're going to do that is we're going to multiply the second row by negative 5 and add it to this one, right? Because negative 5 times 1 is negative 5 plus 5 is going to give us a 0. So we're going to do negative 5 times row 2 plus old row 3. All right? So I'm going to put that here. All right? So row 1 and 2 is not going to change. We're going to have 1, negative 1, 1, and then 8. And then we're going to have 0, 1, negative 12, negative 15. And then row 3 is going to change. We're going to have 0. This is not going to change because negative 5 times 0 plus 0 is just going to be 0. But then we're going to have negative 5 times 1 is negative 5 plus 5 gives us a 0. And then here we're going to have negative 5 times negative 12. That's negative 60. I mean, that's positive 60. And then we're going to add negative 3. So 60 plus negative 3 is 57. So this is going to be a 57. All right. And then finally, right here, we're going to do the same thing. So negative 5 times row 2, which is negative 15. So that's negative 5 times 15 is positive 75. So we have 75 plus negative 18. Well, 75 minus 18 is 57 again. All right, so this is 57. Okay, that's the end of step 4. We got a 1 here and a 0 below it, so we're done. Let's go to step 5. Now remember, step 5 is we need to put a 1 right here, all right, so that we're going to have 1, 1, 1. Now we can do that just by multiplying this whole row by 1 over 57. So the new row 3 is going to be 1 over 57 times the old row 3, all right? And that will give us a 1 here, all right? So let's write our new matrix. The new matrix is going to be 1, negative 1, 1, 8, then 0, 1, negative 12, negative 15 here, and then we're going to multiply everything here by 1 over 57. So 0, 0, 1, and 1. All right? And now we have row echelon form. 1, 1, 1, and then zeros below it. So we can now do step 6, which is just to solve. So we're going to rewrite this as a system of equations. We have x minus y plus z equals 8. And then we know that no x here, so it's just y minus 12z equals negative 15. And then here, what do we have? We just have z equals 1, all right? So now, since we have z equals 1, it's easy to solve the rest of these, all right? Z equals 1, we put the 1 in here, so we'll have y minus 12 times 1, which is just 12, equals negative 15. Well, that means y has to equal negative 3. Okay? So y equals negative 3, z equals 1, and then finally we have x minus y, which is negative 3, so that's plus 3, plus z, which is 1, right, plus 1, equals 8. Well, that's just x plus 4 equals 8, which means x equals 4. And we're done. So we have solved our equation. X equals 4, y equals negative 3, z equals 1. All right, how long did that take? About 10 more minutes. All right, I will get to number 9 and 10 tomorrow. I wanted to get it done. Now, unfortunately, there's a couple of things you need to know. So I won't do them now, but if you see in your homework tonight, if you see a row in your matrix that's all zeros, then I want you to write down that it has infinite solutions. Tomorrow, I'll make a video explaining how we can find those infinite solutions, all right? For now, don't worry about it because I don't have time to go through it right now. We've already had a long lesson today. And then also, if you see one like this where we have zeros for the matrix, for the coefficient matrix, and then a number next to all zeros. If you have 0, 0, 0, and then a number, that means there are no solutions. All right, no solutions. All right, no solutions. Okay, so if you see that in your homework, just write no solutions. If you see this in your homework, write infinite solutions. Okay? That's all for today. I'm sorry. This was almost a 40-minute video. It will be 40 minutes and 5 seconds. All right, but I will see you guys next time. Bye-bye.